This video is on Unit 4, Chapter 8, Intro to Polynomial Functions, Lesson number 4, Writing Polynomial Functions from Roots. Or my favorite way to say that is working backwards. We are going to write polynomial functions from roots. Now, we've done this already when we were studying quadratics. We wrote quadratic function from the roots. This one is the exact same process, just a little bit longer. Because think about your polynomial functions. We may not have just a quadratic. It might be cubic. It might be quartic. It might be quintic. So these problems can get a little bit longer. In the notes here, it says you will use the roots or the zeros, which of course are your solutions, to work backwards to find the original polynomial function. Remember that your roots or zeros are what x is equal to. So again, anytime it says x equals a number, like let's say 5, that is a solution. That is a root or a zero. That's the form that you're looking at. Factors are the binomials that multiply to create the polynomial functions. So if I subtract the 5, I now have x minus 5. That is a factor form of that solution. Also, the other thing that you have to remember, which a lot of students do forget, is that your complex roots, which are the i's, and your irrational roots, which are your radicals, come in pairs. They always come together. One's a positive, one's a negative. The steps here look exactly the same as they did before. You're going to set x equal to each root. If the root is a fraction, you're going to multiply the equation by the denominator. Use opposite operations to get a zero on one side. So basically, again, you're changing it from the solution format to a factor format. Then you're going to multiply all of your factors together, and you're going to write in function notation. So looking at example number 1, we want to write the polynomial function with the given roots. So I got 3 solutions here, which tells me that that should be x cubed. This would be a cubic function when we're done. There are 3 solutions. X times x times x is x cubed. So the first step is to take x equal the number, so x equal the root, and then we're going to use opposite operations to make it a factor. So add the 3, x plus 3 equals 0. So there's my first factor. X equals the 1/2. Multiply by the denominator to get rid of the fraction, and then use your opposite operations to turn it into a factor. And then the last one is x equals 1 minus the 1, again, to make it look like a factor. So we have to take our x plus 3 times our x minus 1 times the 2x minus 1 to come up with the polynomial function with those 3 solutions. So just like in lesson number 1, we cannot multiply but 2 things at a time. So I'm going to take the first 2 and FOIL. X squared minus x plus 3x minus 3. That's going to simplify down to x squared plus 2x minus 3. And I would recommend that you always look for those common factors or common terms, those like terms. Simplify that as much as possible before you go on to multiply that last set. So x squared times 2x will be 2x cubed. X squared times negative 1 is a negative x squared. 2x times 2x is a positive 4x squared. 2x times negative 1 is negative 2x. And then last, negative 3 times 2x is negative 6x. And negative 3 times negative 1 is positive 3. Combining all my like terms, 2x cubed plus 3x squared minus 8x plus 3. Please put this in function notation. We are writing the function. So make it a function. It is not an expression. It is a function. Looking at example number 2, we have a fraction, negative 2/3, and 2i. So, and there must be a typo here. There's not supposed to be a comma. This is also cubic because your 2i is not just positive 2i, it's also a negative 2i. So I'm going to take my x equals the root, and for the fraction, I'm going to multiply by the 3, and then add the 2, and now it's in factor form. X equals 2i, subtract the 2i, and there's my second factor, and x equals negative 2i, add the 2i, and there's my third factor. So I'm going to take my 3x plus 2 times x minus 2i times x plus 2i. And hopefully you're still listening. When you guys go to multiply this, make sure that when you have i's or radicals, that you multiply those things together first. So I'm going to multiply my x minus 2i times my x plus 2i. X times x is x squared. X times 2i is a positive 2xi. Negative 2i times x is a negative 2xi. And then negative 2i times positive 2i is a negative 4i squared. Now I'm going to clean this up. The 2xi and the negative 2xi go away. I squared is equal to negative 1. So negative 4 times negative 1 is a plus 4 there. And that's going to reduce to x squared plus 4. And that's going to multiply by the 3x plus 2. So 3x times x squared is 3x cubed plus 12x plus 2x squared plus 8. Now, that's not in standard form. Please make sure that these are always in standard form. So 3x cubed, then the squared term, then the linear term, and then the constant. Please do not forget your f of x out front. And there's that answer. I will look at example number 5. Example number 5 is also going to be cubic. 2 plus radical 2 is also 2 minus radical 2. So I've got x equals 2 minus the 2, and there's my first factor. The next two are a little more complicated. We need to subtract the 2 and subtract the radical 2. And there's my next factor. And then the third one, x equals 2 minus radical 2. We're still going to subtract that 2, but we're going to add the radical. And there's my third factor. So my three factors are x minus 2, x minus 2 minus radical 2, and x minus 2 plus radical 2. And I say again, please make sure that you multiply like things together. So the two factors that have radicals in them need to be multiplied together first. X times x is x squared. X times negative 2 is a negative 2x. X times a positive radical 2 is a positive x radical 2. And then the negative 2 times, x is negative 2x. Negative 2 times negative 2 is a positive 4. And negative 2 times a positive radical 2 is a negative 2 radical 2. And then lastly is the negative radical 2 times x. I'm going to come down below, is a negative x radical 2. Negative radical 2 times negative 2 is a positive 2 radical 2. Negative radical 2 times a positive radical 2 is just going to be negative 2. Some folks are still struggling with the radical times a radical. The radicals go away, leaving you with just the number underneath. All right, now let's clean this all up. There's only one x squared, so x squared. My x radical 2 and my negative x radical 2 cancel each other out. We have a negative 2 radical 2 and a positive 2 radical 2 that are also going to subtract out. have a negative 2x and another negative 2x giving me a negative 4x. And then 4 and a negative 2 is a positive 2. So all of that reduces to x squared minus 4x plus 2. And then we're going to multiply that times our x minus 2. So x cubed minus 4x squared plus 2x minus 2x squared plus 8x minus 4. So I've got x cubed minus 6x squared plus 10x minus 4. F of x equals, and there is your answer for number 5. So the steps are identical to the ones that we used when we were working backwards with just quadratics. But again, these can be cubics, they can be quartics, they can be quintic. They are polynomial functions. We're writing the polynomial functions. So again, those are your notes for lesson number 4 on writing polynomials from roots.